Hello everyone, and welcome to this lecture on chemical, electrochemical, and gas sensors. I am Parthojit of Institute of Innovative Research, Tokyo Institute of Technology, Japan. The topic of my lecture is polyaniline-atomic AU modified platinum electrode with ionic liquid as configuration for enhanced electrochemical sensing. Without further ado, let's get started. This research is motivated by the field of machine olfaction. Recent advances in understanding of the human olfactory system has led to the development of sophisticated biomimetic systems, at the heart of which are biomimetic systems such as gas sensors and transducers of variable selectivity. Artificial systems implemented using gas sensors with various selectivities have been able to characterize properties such as air quality, toxicity, odor, among others. There are various types of sensors available for machine olfaction, such as piezoelectric, electrochemical, biosensor, piezo-resistive sensors, and others. The electrochemical sensor is of interest compared to its counterparts due to its many advantages, such as low cost of production, no humidity interference, which leads to many tunable properties, such as modifying the electrode, the electrolyte, and even the measurement technique. This research thus focuses on the improvement of electrochemical sensors with novel sensing materials. Let's explore further. From other works of heterogeneous catalysis, it has been shown that when a size of metal is reduced to nanoparticle size, its catalytic activity is improved. This activity is further enhanced when the size is reduced to monoatomic metal size. Curated structure of atomic gold can be and have been formed on conducting polymers such as polyaniline. Figure 4 shows the fabrication process of a single atom of gold on polyaniline or pani conducting polymer through a bottom-up electrochemical process. Polyaniline can be oxidized to create a metal binding site, and a metal ligand bond can be formed by a suitable metal precursor. In our group, we have prepared atomic gold nanocomposites with different numbers of gold atoms. Such nanocomposites exhibit an odd-even activity, which was confirmed with cyclic voltammetry of electrooxidation of alcohols in alkali medium. A dataset of electroanalytical responses from 4 target compounds towards lower aliphatic compounds reveal unique oxidation peaks. Principal component analysis is capable of discriminating between the different target compounds. However, the electrochemical cell with modified macroelectrode is bulky and not suitable for real applications. Furthermore, the aqueous electrolyte is susceptible to drying up and is not preferable for long-term use. In order to address these issues, sensing on a planar substrate with viscous electrolyte is explored. In order to complete the electrochemical cell with viscous electrolyte, a suitable reference electrode is needed, which is explored as well. Thus, we focus on the following sensor platform. A pani film polymerized on planar substrate can be further modified with atomic metal for enhanced activity. Room temperature ionic liquids are used as electrolytes due to advantages such as wide electrochemical window and low vapor pressure. Such electrochemical sensors are expected to yield high selectivity due to the tunable parameters. With this configuration, a large number of selective layers with partial selectivities is possible, which is essential for machine olfaction. Let's look at the materials and methods. A commercially available platinum integrated electrodes were electropolymerized to form polyaniline film. The film density was confirmed with scanning electron microscopy at 5,000 and 10,000 magnifications. Figure 11 shows the sequence of the sensor fabrication process. In the case of formation of pani, the typical cyclic voltammogram of pani is shown. There is variation in the voltammogram after pani AU2 formation due to the degradation of Pani. The atomic gold decoration of polyaniline was implemented inside a flow cell as shown in figure 12. The voltage time and current time response of controlled growth of biatomic gold on Pani or Pani Au2 is shown in figure 13. As it can be seen, a long rinsing process with perchloric acid buffer solution is imperative for removing excess gold atoms. Pani, in its imine form, thus forms an isolation matrix and is capable of spontaneously being reduced by the metal precursor. In this research, KAuCl4 was used. Final status of the planar electrode is shown in figure 14. The response of Pani Au2 film towards electrooxidation of propanol in KOH alkaline medium is shown. From figure 15, it can be seen that although Pani film shows electrooxidation peak for N-propanol in alkaline medium, in the presence of biatomic gold, the peak is enhanced to about 4 times the current density. For this experiment, the platinum reference electrode on planar electrode substrate was used. Catalytic activity is confirmed from the electrochemical response. However, the electrochemical response in acidic medium is different than alkaline medium. Cyclic voltammetry was measured with commercial AgAgCl reference electrode and platinum of planar electrode respectively. Results show that depending on the type of the reference electrode, the redox process is different. For planar electrodes, the commercial reference electrodes are bulky. Therefore, on a planar substrate, we investigate on AgAgCl ink in order to reduce the form factor of the sensor. Finally, the configuration of the planar electrode is also tested with room temperature ionic liquids as electrolyte. It is shown that once again, for room temperature ionic liquids, depending on the choice of reference electrode, the cyclic voltammetry is different. This response was confirmed for both pure ionic liquid and ionic liquid with N-propanol in a 5:1 ratio. For AgAgCl ink as a reference electrode, the electrochemical response is acceptable, although it appears as a skewed shape of the voltammogram with perchloric acid only. Finally, the conclusions so far. This research proposes a novel configuration by which polyaniline-atomic AU nanocomposite can be implemented on planar electrodes. Planar platinum electrodes have been electropolymerized with polyaniline, and the polymer matrix has been decorated with biatomic gold electrocatalysts. Results show increase in the electrocatalytic activity for the oxidation of alcohols in alkaline medium. For real applications, room temperature ionic liquids are a suitable choice over aqueous electrolytes due to their many advantages. Lastly, AgAgCl ink reference electrode shows enhanced sensor response over bare platinum as a pseudo-reference electrode. Currently, we have confirmed the operation of the configuration of polyaniline on planar electrodes with room temperature ionic liquids. We have also separately studied the polyaniline electrode with atomic gold decoration. In the future, the 3 features will be combined together to yield an electrochemical sensor with high selectivity. Later, multiple such sensors will be prepared to prepare a sensor array towards machine learning and embedded systems. This is a representation of our concept. In the future, we would like to realize something similar. That is the end of my talk. I hope you enjoyed this lecture. Thank you for your kind attention.